Hello, everyone. Welcome back. We have 2 more sessions left today. The first one here is understanding your players using near real-time game analytics. And this is going to be Michael Manoochehri from Google, that search company you've probably never heard of. And then we also have from Staq, Luca joining us to talk about how they've used Google BigQuery to build their game analytics solution. And so they're going to be starting here in just a second, but then the last session that starts at 4:30 is going to be how EA builds mobile game servers on Google App Engine. So hope you can all stick around for both of these, and welcome, guys.
Hello. Can you hear me? Hi, I am Luca Martinetti, and CTO of Staq. Staq is a brand new startup that is started in Techstars. Today it's a 3-man army. It's me and these 2 guys here, Massimo and Francesco. With a big vision, we try to build a game management platform, and I'll try to explain a little bit better what we believe this means. Today, I'll be talking about how to understand your player using analytics and how to do that in real time. And I have to say thank you, Google, for having us here. And that's because we use a big chunk of their analytics offering, BigQuery. All right, so you are a game developer, so you probably want to build a game. You're here to build a game. And what I'd say is, nope, no more games. You're not shipping boxes anymore. Market is so changed. What you're actually doing is you're building a service. Building a service is very different from shipping a product, has a complete different set of challenges and requires different state of mind and different procedures. Building a service means that it's always on 24/7. Somebody's always interactive with your game and generating events, generating data. And at a certain point, if you're successful, and that's a problem you want to have, you'll understand that you're sitting on a giant data fire hose. Spoiler, in this fire hose, there are so many interesting things you want to learn, you want to try to grasp. In order to do that, we believe you should set up a process made of 3 steps. Measure something, so collect the data, try to understand something you don't know before, and react. React in a way that can make your game better or your monetization stream better, so actually your life better. Yeah, that's the 3 guys there are us, looking at the big screen. And this is the flow we want to enable at Staq. So starting from an event that could be an in-app purchase, try to understand something new through analytics and data analysis, and then react somehow with a promotion or with a discount, with a game change, and so on. So today, I'll try to explain a little bit more in details how to collect data in the right way, and how important is have a way of running queries very efficiently. Because these are, at the end, the 2 important steps that will enable all the rest of the process. So collecting data, what do you want to collect, what do you want to measure? It depends. It depends. There are so many options that some of those are game-specific, some are common to different kind of games. What is important is that you should try to collect a piece of information that happened in a certain point in time that is an event. That's the JSON schema that we use. What's happening here is that at this timestamp in this fictitious game, this was this warrior that was at level 7, and with these 2-handed big sword was raging and hitting somebody and create some damage. So this is a typical event you want to collect from a game. And using Staq, you're not enforced to any specific schema, and we'll talk about that more in details later. So you start collecting these guys, and you figure out that you have tons of data. What does it mean? It depends. It depends greatly on the traffic you have, on how much you're instrumenting your game. But if you're successful, if your player base is significant, at a certain point, you'll have to manage gigabytes per hour. This means that many of the solutions that classical architecture with a MySQL database are not good anymore. Not good anymore for the amount of data and the velocity. And there are some caveats, some very important things you have to consider. And this is the biggest one, that you cannot pre-aggregate. It means that you cannot take just some piece of information increment counters. You need to keep the raw data, all of it. Why? Because at a certain point, you'll come up with new questions that you didn't have beforehand. Or you have new data points that will make extremely different the story of a player, for example. Let's say you're using an advertising network, and at a certain point in time, you receive the list of the players you bought from that specific channel. So you need to reconcile this data with your history of events. So you need a system that can handle tons of data in the raw form, because that will allow you to ask new questions over time and integrate the new data points when they come. Sorry. I'll talk about the kind of data warehouse we're building to offer our analytics platform and the tech solution we chose. We're so proud of what we're building that we choose this double buzzword, the real time. That means 2-time real time. Why that? Because we ended up choosing to use 2 different data stores for answering the same questions. We're building a system that allows you to run the very same exact queries on 2 different databases that has some different performance profiles, and allow you to have always the freshest data available, and at the same time run analysis and run the same queries on all your historical data set. So if your game has been around for 1 year, you want to be able to answer a question about what's happening now and how this trend developed in the last year. We're building on top of 2 technologies that are very different. One of that is a database that is called MemSQL, that is an in-memory version of MySQL. It's a startup as well. It's here in San Francisco, YC startup. That is pretty cool because it keeps all the data in memory and allow you to do very fast aggregation. At the same time, we're using this excellent product from Google that is called BigQuery, that is a database as a service, you could say, for analytics that allows you to run queries real fast on gigabytes of data or terabytes without having to manage the whole infrastructure. So our design goal was to be awesome fast on the latest buffer of data. So it depends on the size of your game, but it could be the last day or last weeks, and be really fast on all the historical analysis. What we love about BigQuery is that, as I was saying, is offer as a service. And if you're a 3-man companies like us, don't having to manage a big cluster, like an Hadoop cluster, for example, even if it runs on a cloud provider, it's a big win. Because you just take a service and you know it will be working at night, 3 a.m. It allows you to do fast ad hoc queries on large data sets, and has a very nice feature that is called nested fields that allows us to manage the tags that we associate with every event. And so it's a little bit broader in the data definition than a row of a table in a database. It's as fast that sometimes you don't understand how much data you're touching, and the pricing model is actually based on the amount of data your queries are touching. So I was running a demo a few months ago, And that's what happened. I ran a query on 2 terabytes of data, and I said, what? Because that's what you see in the build. So it's so fast that you really don't understand how much data you're touching in a single query. And so, yeah, we love it. And yeah, when the bill came, I was like this. Let me introduce Michael, and then we'll talk more about BigQuery, and I'll continue later.
Thank you, Luca. Can you guys all hear me? Yeah, that sounds like a yes. Yeah, so I'm going to do my best Futurama Fry impression and say I don't know if I'm happy to see Grumpy Cat or sad that it was used in the same sentence as BigQuery. But anyway, yeah, so I'll talk a little bit about how to integrate the BigQuery API into your application. So for those of you who don't know, BigQuery is an API that lets you ask questions about large data sets, your own data. I'm not going to get too deep into the technical details. I'm actually going to show you sort of how it works. BigQuery is an API in which you can send messages to it in JSON format and then retrieve query results in JSON as well, which makes it really easy to incorporate into your existing applications. And what I really like about the Staq story is they've got their existing application. I think you build mostly in the cloud. And BigQuery, it's easy to integrate BigQuery with that system. So they really understand the kind of modern data pipeline where you have a particular technology for collecting data in real time very quickly and being able to ask questions about that sort of real-time data that's coming in, and then asking quick questions about historical data or aggregate data. That takes a different tool. And so what Staq's done really well is integrate 2 different tools on top of their web stack. So the best way to sort of show you, if you've never seen BigQuery before, is sort of how it works and how to integrate. I have an example here. I tried to build the simplest, let me see if I can make this a little bit bigger, the simplest application that I could using the BigQuery API. So all of the Google APIs that are built sort of on our modern stack have client libraries in many languages. We've got Ruby and Java and JavaScript and Python, PHP, just about everything you need. And we've had open source projects of people building other things because it's just a RESTful API. It's easy to integrate. So this is an example of some code I wrote, just really quickly using BigQuery with the JavaScript API. And what I'm doing here, and I'm just showing you sort of what it looks like, how little code you need to run a query on a very massive data set. In this case, I have a client ID and a project ID that I got from the Google Developers Console. This is something you can kind of read about on the BigQuery website. I don't have a lot of time to get into that part. And I've integrated into this application. I've chosen a scope for authorization of the API. And simply what I'm doing is I'm just running a query, and that query will come from a box, and I'll show you this application in a second, and then visualizing that data, the response from that query, with a chart. So let me show you how this works. Oh, it looks like are we offline? We might actually be offline.
Offline demo?
One moment, please, while we get the network, make sure the network's right.
I can try just switch to Wi-Fi. What do you think?
All right, let's give that a shot. Great. Yeah, looks like we had a network connecting. Okay, so this is what the app looks like. It's really simple. It has an authorization button. So I've actually run through this. It's doing an OAuth 2 authorization, but as you saw, the client libraries take care of a lot of the complexity. And now here's a query. I'm going to use a sample that we have in our public data samples. When you sign up for BigQuery, we have a collection of really large data sets for you to try it out. And so what I'm doing here is I'm sending it a SQL-like query. And what's great about BigQuery is it combines a lot of the best of technologies from sort of big data applications, right? So when you're dealing with gigabytes and terabytes of data, often you turn to MapReduce-based tools like Hadoop, data warehousing tools like Hive, or you're using a NoSQL data store, something like Mongo. BigQuery doesn't use a MapReduce-based paradigm. We actually have a different kind of execution model. Basically, we store your data in a columnar format, and then we do most of the actual aggregation in memory across a very large cluster. So what you're getting with BigQuery is our own infrastructure. But what's cool about it is you can ask questions not by writing MapReduce functions, but in a SQL-like language. So it makes it very easy to iterate. So in this example, in this application that you just saw the code for, I'm going to ask a question about our GitHub timeline. I'm going to say, what are the top The GitHub timeline data, by the way, is a public data set that GitHub provides of any event relating to a particular, any repository that's public. So here I'm asking, what are the top 5 languages that get the most, most events? So let's just run that. Hopefully everything will work fine. In fact, I'm going to pull open the developer console so you can see what the response looks like. So here's an example that took that was a very quick query. This is actually a fairly large data set. There's 30 million records in here, and almost instantly it returned this sort of table. And this is what the response looks like on the JSON side. So I don't know if you can see that, but it's basically just a JSON representation of the table you see. So it's very easy to integrate, right? You saw that small amount of code. I'm able to build a dashboard that's querying this really interesting data set to show you how you can integrate this into your applications. But let's talk about doing this with games. What kind of queries are really good for game things? I was thinking about some queries that might appeal to some people coming to GDC. And when you talk about games, you're often talking about cohort analysis, right? So here's another example of a public data set that we have. Hopefully you can see this. I'll make it a little bit bigger so you can see it. We're going to look at the Wikipedia revision history data set. So this is a very large data set that we have. It's 35 gigs. It's got 300 million records. And let me see if I can actually zoom in a little bit here. Is that a little bit better? Can you see that, everyone? So basically, there's 35 gigs. It's pretty big. It's got 300 million records. And the data kind of looks like this. It's got a title. It has a timestamp, and a contributor ID, like who revised the article, what their contributor's name was. So I was thinking about some queries we could run to kind of demonstrate what a cohort analysis would look like. And so I have some examples here. The first thing I was thinking about people's names, and I realized people like to name themselves, Wikipedia like to name themselves like Wikipedia Mage and Wikipedia Wizard, much like some of the gamers that you have on social media. So the first query I thought of was this cohort analysis. I wanted to see what usernames contain these strings, right? So I wrote a very simple SQL-like query here. And it should go pretty quickly. So in 7 seconds, it did a full table scan of all 300 million records, and it found some matches that look a lot like Mage, and you can see images in there, right? So that was very quick. There's 283,000 records. So I wanted to do sort of an ad hoc analysis. I wanted to iterate quickly. Now, if I was doing this with MapReduce, I'd have to write a new MapReduce function. I'd have to do a new workflow. It takes time. But what I want to do is just ask these quick questions on this huge data set very quickly. So the first thing I want to do is get rid of those image results, right? So I'm going to do a regular expression match, which BigQuery supports. So what I'm doing here is I'm running the same query. And actually, let me take this out. I'll do this in a second. So I'm running the same query. But what I'm doing here is I'm saying instead of the contain string, I'll do a regular expression match on wizard or mage. So I'm going to run this again, and hopefully what will happen is that I'll see a lot, the real usernames that don't have the word image. So we have Pharaoh of the Wizards and Wizard 191. So now I'm getting somewhere. Like I'm building a cohort analysis where I'm actually looking at a particular type of user. Now what I want to do is bucket my results by a time. I want to see who's doing what on a particular day. Again, this is going over 35 gigs, and imagine doing this on something like a MySQL data store or something like that. It would take a long time. But I'm doing these queries in 4 seconds. So I'll do another quick query. I'm going to, let's see, I'll run another sample that's similar. Now let's add a time bucket, and I'll just run through these really quick. What I'm going to do here is I'm going to say, use the function called UTC USEC today, which means it'll take any timestamp it sees and bucket it in a 24-hour period. Basically, what I'm doing is I'm saying, give me events in a particular day. Segment my data like that. So let's run this again. What you're going to see here is something that looks like the same data, but events happening per day, Wikipedia revisions happening per day. So that, again, took just 6 seconds. And now you can see Wizard Man had done a revision on that day. By the way, these are Unix timestamps. That's why they're these big integers in microsecond format. Wizard Man did something on this day. Pharaoh of the Wizards did something this day. Now I'm getting somewhere. I'm seeing what activity is happening per day. And now what I want to do something a little bit different. I want to do something where I can actually segment them as, are they wizards or are they mages? So I've added a conditional. And I don't know if you can see that there, but I've added a conditional statement that actually segments by what type of player or what type of user are they? Are they the wizard player or the mage player? So in just a few seconds, I should get that as well. And basically what this is going to do is break that up by day. And it's going to say, how many wizards are doing something, how many mages are doing something. So here you can see, a wizard interacted this day, interacted that way, and I'm able to break them up into different mages, wizards, warriors, whatever, what have you, based just on their username. And finally, let's do a final kind of wrap it up query. We're going to put this all together. We're going to group things by wizards and mages. We're going to add a time bucket. We're going to format the timestamp. So in just a few queries, you can write these very quickly and iterate very quickly. But I've just done a really interesting cohort where I've said, break it down by day. Mages are revising only 15 times a day, while people with wizard in their username are revising 185. And so on and so forth. You can imagine taking this data and really breaking it down. You can see what type of players you have, what are they doing, what's their behavior. Real quick, we've listened to our developers, and we really care a lot about what guys like Luca are doing at Staq. One thing that they've asked us for is more features to help them do things on larger data sets. Traditionally, the way that BigQuery is designed, it really didn't do big joins on different size data sets. You could do a large data set joined to a lookup table. But we've just a few weeks ago released something we call Big Join, which does allow you to do these very, very large joins on, we've done terabytes to gigabyte data sets, very useful for years worth of activity joined with data coming from something else like purchases. And I was able to ask the Staq team to generate a fake data set, but something like the data that you saw Luca provide, which is kind of like what their events look like. So let me show you a little bit about that. Their events data looks something like this, where you might have a particular user ID, it's just some hash, a timestamp like you saw, they did something, and then the event. So in this case, this data says that a player started at a certain time, started playing the game. Another event might be an in-app purchase. So what if I want to ask a question? This particular data set, by the way, is 6 gigabytes. It's about 30 million records, right? 30 million events. And I'm going to join this data with another data set that's even bigger. It's something like 10 gigs, 47 million records, right? So I'm going to show a big join on that, and sort of see how fast it can go. And what I'm going to do is I'm going to look for players. I'm going to look for players who started a session yesterday or the day before, and then bought something, had an in-app purchase today or the next day. So this is a large kind of a join. It looks a lot like a join you would see in a relational database, and this is joining data from 10 gigabyte to 6 gigabytes. And let's see how long this takes to run. In here, as I mentioned, I'm looking for in-app purchase events that happen in a certain day. I'm looking for the count and the total amount of money, and that just took 7 seconds, right? So I've just did this huge join. That's something that you normally do a MapReduce job in just 7 seconds, which is pretty fantastic. And here, you've got the aggregate queries, the count of purchases, the amount of money, and which user it was. So this is the kind of cohort analysis you can do, and you can integrate this into your own applications using the BigQuery API. I'll leave you with one more thing before I hand it back to Luca, and this is something you can try right now on your laptops. To sort of show this off without having you actually develop something or log into our console to actually start writing code yourself, you can play with this using something we call the BigQuery tour. And this is sort of a cartoon exploration of two really bigger data sets than I've shown you today. One is data from weather stations all around the world since 1929. That's a pretty large data set. And an even bigger data set is a Wikipedia page views data set, which is a really interesting one. Let's look at what the top page views were for last year. Today's the 26th, right? So let's see what happened March 26th. Does any guesses of what the top Wikipedia page viewed was a year ago? Think about it. I'll show you. So I'm going to run this. This is doing the same thing. This is an app built on the API, no caching. It's hitting BigQuery's API live. It's crunching and crunching. That's actually what BigQuery looks like inside of Google. I don't know if you know that. We do have ping pong balls. So 10 seconds, we've analyzed 83 gigs of data, very quick. Let's see what the results are. Looks like Hunger Games. I guess Hunger Games had just come out. So everything is Hunger Games, except for number 4, Ludwig Mies van der Rohe. Does anyone know why he might have had one of the 4th largest Wikipedia page views? Any question? Yeah, it was his birthday, but we also had a Google Doodle. And whenever there's a Google Doodle, the Wikipedia page views are enormous on that day. So that's actually what happened. So there you go. You can also look at the queries through this. It's really great. You can get to this by going to cloud.google.com/BigQuery. And you can just play with it yourself. Or just Google search for BigQuery tour. It's probably going to be the first hit. So that's it. That's what BigQuery does. I'm going to pass it back to Luca, and he can show you how to integrate it into a real app.
All right. OK. Yeah, the cat. All right. So after collecting these events, second step is try to understand something that you don't know. And these analyses can be of very different kinds. There are the standard metrics that every single game app needs. So daily active user, monthly active user, revenues per user or per paying user, and the churn rate. So how long my players are staying with me in next day, in 7 days, in 30 days. And also these, let's say, easy metrics, these standard metrics, have some challenges when I'm talking about monetization. For example, when I'm dealing with in-app purchases, one of the biggest problems that we're facing are fake transactions. What does it mean? It means that for very large studios, if you don't do server-side verification of the respite, so if the purchase that a game is reporting to you is real, you see just 1 in 100 transaction that is an actual real transaction. And that's, it's not that bad that you're giving away virtual goods because you're not paying for that, but your metrics will be barely usable with all that noise. Why does this happen? Because the devices are not secure, and if your user base is large enough, somebody will spend time, nights, and hack the game to get that great sword for free. And you start getting fake events. So solution for that is having server-side respite verification. So with the Apple App Store, for example, with Google Play, they expose an API, but so you're not only at this point running the game on the device. You need a server-side part. And that's something that Staq provides out of the box. So what I want to show you, it's a demo of these basic metrics. And obviously, hope everything goes well. I don't always test my code, so I will do it on stage now. So live coding. So this is the dashboard of Staq. And what I'll do now is create a new application that I'll call GDC Demo 01. And creating this application, I will get an app ID. All right, let's switch to that. I should see some nice zeros. And what I'll do is take this app ID and just paste it into this small Python script that is a simulator that we'll call our REST API, simulating some events, some users logging in, and some purchases. So let's start it. I have connection. It's not very popular yet. Don't have any user. OK. I can see in real time my users coming, and those are generating some events. I see some events flowing in real time, so some sessions are started. If these guys, somebody bought something, I see the revenues going up, and I see the basic metrics in real time. So that's what I was talking about before. The last buffer, it's all in memory. So we're able to have all these metrics and also custom metrics that I'll show later really, really fast on your data. And this was really quick to set up. So if you have a game, you just plug in our SDK. We have, as I was saying, REST APIs, and we also provide Unity, JavaScript, and iOS, and Android will be out very, very soon. And this is part of the story, so understanding how much money you're making in a reliable way. But that's not all. That's not enough. You need to ask new questions. You need to understand something that is specific for your game. As Michael was saying, are mages spending more than warriors if you're doing an RPG, for example? Or are mages that reached level 7 and used this specific sword performing better than these other class of players? And this can be very arbitrary. So why are they not buying the dead bird? Why? So cute. It's this item for Team Fortress 2. It's only $12. Why are they not buying that? I think they're actually buying it. So there are so many questions that are really specific to your game, and you need a quick and effective way to go against the raw data. And I want to show something that is even more difficult than what I did before. So again, demo gods, please help us. Okay, I have this small HTML5 game that I found online from a guy in Belgium that is a beatbox. And what I'm going to do now is just plug the Staq API in that and start tracking some events. So let me load it up. Okay, so it's just HTML5, so just a few JavaScript file and CSS. It runs on the canvas. What I did is just adding the JavaScript client of Staq of the REST API that's a few lines long. It's very, very simple. And what I'm doing now is finding where the event of somebody hitting the button goes. And it goes here. Let me paste some code that I have ready. Where is that? Here. Okay. So I have an integer that is the ID. Can you read it, or is it too small? How's the size of the font? Is it too small? That's fine? Okay. So I have an integer that is the triangle I've been clicking on, and I just did the small map of the colors. So what I'm doing, oops, I haven't copied that. Okay. So what I'm doing is creating an event. And the event looks like this. As a timestamp, it's a custom event that I'm calling beat. Maybe you can zoom it a little bit. Yeah. It's an event that I'm calling beat. As a value, it takes the color of the ID I'm clicking on. And I'm just adding two metadata. One is the tile ID itself. And I'm setting a flag that says green if the ID is 12 or 15. So this is the IDs of the different tiles. Okay, so what I need is just create the event, and I have to put the application ID here. Oops, what was that? What was that? Okay. So let me create a new application, and I call it GDC beat01. And get the app ID, copy that, switch to that. Oops, other side. And I paste it. Okay, here we go. What I'll do is get comment. Gods, help me. And I'm pushing this small demo. Do a little dance, do a little dance. I never touch my code. Yeah, if you have iPhones or iPads with you, would be nice if you could go to this URL that I'll give you in 1 second. That's live publishing. Come on, go there.
It works on laptops too.
Demo gods, are you helping me today? Okay, in the meantime, I'll give you the address. Cleaning up, installing, so it's happening. Sorry for that. I haven't found a faster way of deploying my application. Yeah. Okay, here we go. So if we go to this URL here, beat.staq.io, please do that. It's not beta, it's beat. Do you have iPhones or iPads with you? I have an iPad, maybe. And just load a page. Okay, 7. 7 of you guys are on the page now. I can see that. And you're sending bits. Are you playing? I can hear you very loud. Turn up the volume.
I want to hear some more, too.
Want to hear some more?
We need
Is
big
it loading?
data.
This should be working on iPhones and Androids as well. But not. Hey! Is it working? Okay, so you see the events flowing in real time. And that's kind of interesting, but not super interesting. So what I want to do, while you bang on it, is show you that we can do custom queries. So with the SQL syntax that I was saying would be the same for real-time exploration and for all the historical data, I can just say select count the distinct event ID from my table where the event will be bit. And I want to do that on the last minutes. Yeah, you banged on it 2,000, almost 3,000 times. Okay, nice. And since I'm storing the raw data and I'm against the raw data, I can go down to the second. So if I'm lucky, come on, guy. Yeah, that's very fresh data. That's what's happening in real time. So if you stop playing, guys. Stop playing. Stop it. You'll mess my demo. This will go down. Here we go. And at the same time, I had some value that was a string that I put with each single bit that was the color. And I say group by string. Here we go. All this mess here is the different colors that you're clicking on in real time. So let's go green, everybody. Let's start eating only the green ones. We should see only the greens going up. Okay, so imagine this is some real data, and I'm showing, for example, wins versus losses for two specific classes. So what I'm doing, I'm slicing data in real time. And this is quite nice because I can go on different resolutions in terms of time. So this is down by the second, so it's more interactive. But what is useful is that I can see this data in my dashboard like all the rest. So I can just pin this query and see these are bits by color, and I just add this to my summary. So when I go on my dashboard on my summary page, I'll have it here like any other metrics that are built in. We'll enable more data exploration without coding for non-technical user with a query builder. But the idea is that since we're creating our product on top of two very powerful big data technologies, we can go down to the single event every single time. So adding features, slicing, and will be very, very easy in the future. So I was imagining this to be more loud than that, and I had an Harlem Shake here, having you beat in the real time on top of that, but you're so shy, guys. I was imagining all banging on their iPad, but that's fine. Okay, and so this was the asking new question, asking custom question to your data and try to understand something. Last step will be, credit for the game goes to this guy here. Thank you. Last step will be change something, having the option to react to, once you understand something, change it. It can be a game design change because you understand your players are stuck at a certain level or spending too much time on a certain puzzle. Or it can be something like re-engaging players for a specific cohort or trying some hypothesis, like running a test against a specific subset and see how it goes. This is something that I will not show you today. We're launching our beta, so if you're interested in trying Staq, please come talk to me. Thanks again for Google for having us. And if you have any questions, we're here to answer. Thank you. Any questions?
If you guys have any questions, please come up to the microphone so we can hear your question.
No questions? Okay.
All right.
Was very clear.
Yeah, I hope so. So great. So like you said, if you want more information about either of these products, Staq.io and developers.google.com/BigQuery. And it's easy to reach us there as well, at least on the Google side. Join our Google Plus page, the Cloud Platform Developers page. And we were asked to tell you guys, please fill out your mobile survey feedback. The GDC is really interested in that as well. Great. OK, we'll be up here until the next session. So thank you very much.
Just standing and staring at you. So no pressure.